Welcome to aminacademy.com. In physics, let us discuss about a motion of projectile thrown horizontally. Look at this figure. Let an object or a ball which is kept at the point A and it is thrown horizontally with velocity u. Now the point A, which is h from the ground. Now the object acquires a constant horizontal velocity u everywhere, and this is a constant through ox direction, but this ball have vertical velocity also, and which is continuously increased because the earth gravity. Because of this increasing velocity, the gravitational force act downwards to the ball. Now the two velocities are, that means horizontal and vertical velocities are independent to each other. Now let us discuss about the path of the projectile. Path of the projectile. Here consider at point C in the path. So the initial velocity, horizontal velocity is same as its initial velocity, equal u, and vertical distance the horizontal velocity is u at A also. That vertical distance of the A from the ground is h. Now at point A, the horizontal velocity equal u, and vertical velocity, let it be vertical velocity equal suppose u2 here, this point. Now by equation of motion, we know that s equal ut plus half at square. At point A, that means s equal to h, u is 0 because it have no vertical velocity, because at the initial point no vertical velocity, and 0 into t plus half a acceleration is here due to gravity g and t square. Therefore h equal 0 into t is 0 only, h equal half gt square. Now see at point A, initial horizontal velocity we have u, and horizontal distance by the object at time t, suppose t is x, we keep it. Now means the horizontal distance by the object at the time t is, keep it here x, Therefore, we know that x equal horizontal velocity into time t, which is equal x equal u into t, which gives t equal x by u. Now we have the equation already, y equal half gt square, which is further equal half g, substitute t as x by u whole square, which is equal half g x square by u square. Or we can keep it in simpler form, y equal k x square, where k equal half k equal g by u square. Now this above equation, that is y equal kx square, is the equation of parabola, is the equation of parabola. That means a path of a projectile is a parabola. Now we'll talk about the resultant velocity at point C. Here at point C, we will calculate the resultant velocity. Let us draw a small figure like at point C. Here horizontal velocity is u, vertical velocity is suppose u2, we keep it, and the resultant of that both velocity at angle theta from the horizontal is here. This is a resultant velocity that we can use it. Suppose v. Here we can write at an instant of time t, suppose let the body is at C. So at A, the initial vertical velocity is 0. Therefore u1 equal 0, and horizontal at point A horizontal velocity is ux. You can keep it ux, that is u, and at C the vertical velocity is u2. From the equation we know that v equal u plus at, means final velocity equal initial velocity plus acceleration into time. Here final velocity is your u2 of vertical final velocity, and u1 is initial vertical velocity plus a is here g t. Therefore we can write as here u2 equal 0 plus gt, because initial vertical velocity is 0. Therefore we can write u2 equal gt. Therefore resultant velocity at c equal ux square plus u2 square equal ux is u square plus u2 is gt, that is g square t square under the square root. Therefore, the direction of v is given tan theta equal u2 over ux, which is equal gt over u, means tan theta equal u2 over ux, that is gt over u, where theta equal angle between resultant velocity to the horizontal. Next, we'll talk about time of flight. Here, the time of flight, that here the OB, suppose the point here O, the point B is here, the horizontal distance OB equal R, which is called range. Time of flight and range we'll talk about. Or now we know that R equal distance equal initial velocity u and time of flight tf. At A, we know that initial velocity equal to 0, that is u1, the vertical distance is that is vertical distance traveled by the object or ball in time tf equal, suppose keep it sy, or that is h. Now we know the distance formula in equation of motion. Suppose sy equal u1 tf qt, that is half g tf square. Now substituting the value, known value, substituting the known values of, that is h, instead of sy we are keeping h, at initial, that is initial velocity 0 and into tf plus half g tf square, which gives 0 into tf is 0, therefore h equal half g tf square. From that we can find tf equal 2 square root of 2h over g. Now we got the time of time of flight, that is Tf equal to square root of 2h by g. Now we know the equation, that the range R equal u into Tf. I will substitute the value of Tf. Then for R equal u into square root of 2h over g. Then we got the equation of the range as well as the time of flight.